Hello everyone, welcome to my video on circle theorem. In this video, I will walk you through 7 different circle theorems. Now I'm going to make them very easy for you to understand, okay? Because there's another video after this where I have a detailed solution to different many problems on circle theorem. Okay, so without wasting any further time, let's dive in straight to the first circle theorem number 1. Now the first theorem says that the angle subtended at the center of a circle is twice the angle subtended at the circumference. Now the word subtended means made. So we could really read this as the angle made at the center of a circle is twice the angle made at the circumference. Now I've got a circle here, okay? You can see the angle made at the center is actually twice the angle made at the circumference, okay? Alright, so let's move over to the right here to explain what that really means in detail. Now, if we have an angle here, really the question really says work out the size of angle A. This is angle A. Now, the angle made at the center is 88 degrees, and the angle made at the circumference is angle A. So we're going to really look out for the angle A. Now, we know from theorem number 1 that the angle at the center is twice the angle made at the circumference. So if the angle center is 88, definitely angle circumference is going to be half of it. So definitely angle A is going to be 88 degree divided by 2, and that's going to be half of it, and that's going to be 44 degrees. So the angle A here is 44 degree. Okay, so we're going to move on to the next second theorem, and this one states that the angle between the tangent and the radius is 90 degree. Now go to circle, and then you got the radius from center O down here, and then you have a line going this way, which is actually the tangent. Now the tangent is a line that touches the circumference of the circle but without crossing through it, okay? So now this theorem says that this radius always meet this tangent at 90 degrees, okay? So let's move over to the right to show how this really works. So here in this example, we need to find the size of angle X. Now we see we have a radius from center O down here, and then we got a tangent right under the circle, okay, touching the circumference of the circle up here, and a line from 0 O to this point. Now we've got a triangle here, okay? But first, we need to understand that we need to see and understand really that the line drops the center of the circle, meeting the tangent here, always will make an angle of 90 degree. So now we've got a triangle here, so it's not easy for us to work out this angle X because these three angles here, if you add them up, it's going to be 180 degrees. So one way we could do this, a very easy way to do that, is to add up these two angles, 75 and 90, and then subtract the sum from 180 to get angle X. So let me show you how this is done. So I'm going to add 90 degree here and 75 degree, okay? If I add this, I'm going to have 165 degree. Now, to get angle X is to subtract this sum from 180 degrees. So 180 degree subtract 165, and that's going to be 15 degree. So angle X here is going to be 15 degree. Okay, so we come to the third theorem. The theorem says that tangents which meet at the same point are equal in length. Now, let me explain that. You got two tangents drawn up here, meeting at this point. Now, these two tangents, one in red and another also red, are always equal in length. That's what it really says about, okay? And that's why you see this line here drawn here, meaning that this line, this tangent here and this tangent here are always equal because they meet at the point here, okay? Now coming over to the right, let's see an example. Okay, here we need to work out the size marked X. Now we've got a circle, and then we have a tangent drawn here and another drawn here, meeting at this point here, and then we need to work out the angle X. Now one thing we know about this theorem is that if these two tangents meet here, definitely the length of the tangent is going to be equal, okay? And now we got a triangle here, and because if these two legs here are equal, it definitely means that this triangle is an isosceles triangle. And one thing we know about isosceles triangles is that the base angles are always equal. So if the angle here is 70 degrees, this angle definitely has to be 70 degrees also. And so we've got two angles known, and an unknown angle x. To find angle x, you need to add up these two angles and subtract from 180 to get angle x. So first, let me add up these two angles, two base angles. So 70 degrees, add another 70 degrees. This is going to give us 140 degree. Now I'm going to subtract this value from 180 degrees to get the angle x. And if I subtract this, this is going to give me 40 degrees. Okay, well, that's very easy to find. So angle x definitely going to be 40 degree. I hope you really see this was very easy to work, right? Okay, now moving on to theorem number 4. Now this term says that the angle at the circumference in a semicircle is a right angle. Now you can see a center, you can see this triangle with this passing through the center and making an angle at the circumference. Now very important, you notice that this line passes through the center O, okay, and it makes an angle at the circumference here, and this angle is always 90 degrees. Very easy. Okay, all right, so let's move over here to see how we could solve this. So now here we have a problem that we need to find the size of angle x. Angle x. All right, now you notice that this line passes through the center and the angle from the triangle meeting here the circumference at 90 degrees. So I can just quickly put here 90 degree. Okay, make it easy for me to remember. Now I have a triangle here, and I can find this angle x by adding up these angles to be 180. And one way to do that is add up 90 and 55 and subtract it from 180 to get angle x. So let's go straight. So I'm going to add 90 degree here and 55 degree. Okay. Now if I add these two angles together, I'm going to have 145 degree. Then to find the angle x, I'm going to subtract this value from 180. So 180 degrees subtract 145. I think I'm going to have 35 degree. Good. So the angle x is going to be 35 degree. Very easy, right? Okay. So we come to theorem number 5. Now this term says the angle in the same segment are always equal. They got a circle and they have a segment here, another segment here. Now the angles on the same segment are definitely the same. Okay, that's very easy to remember, right? Yeah, so let's go straight to an example. Now here we need to find out not just one angle but two angles E and F. Now we've got a circle here and we've got different lines drawn on it, and then we need to find an angle E and F. Now if you look at this and compare the theorem number 5, we know the angle on the same segment are always equal. And that presupposes that this angle E should be equal to angle 39 degrees. So definitely E is going to be 39 degrees. That's quite very easy. Okay, that's going to be 39 degrees. And then we need to find angle F. Now there are a couple of ways you could find angle F, but I know the angle F here is definitely going to be the same angle here. Okay, all right, definitely, because that's what says theorem 5, the same segment are going to be angles in the same segment are going to be equal. Okay, so what I can do here to find this angle here is definitely going to be equal to the angle F. Okay, so I can just take up this triangle here. Okay, this angle E5 and another angle. These three angles should add up to 180 degrees because they are the sum of angles in the triangle. Okay, so what I'm going to do first is add up 39 degrees and 85 and then subtract the sum from 180. Okay, so to do that I'm going to add up first 85 degree and 39 degree. Okay, so if I do the addition here, I'm going to have 14 here, carry 1, 11, and plus 1, 12. So 124 degree. Then to get this angle here, I'm going to subtract it from 180. 180 subtract 124. I'm going to do 6 here. So 56. Good. 56 degrees. So this angle here is 56 degree. And if this 56 degree, definitely F is going to also be 56 degree. Quite easy, right? Okay, let's move on to theorem number 6. Now, this theorem states that the angle between a tangent and a chord is equal to the angle in the alternate segment. That means this angle here is always equal to the angle here. Now, we could also make an argument that the angle here also. Okay, I'm going to put that in blue to make it to make you really see what's happening here, is always also equal to the angle made here. We could make the same argument, okay? All right. Okay, so without wasting further ado, let's come over to right here to see how we could solve this. Now we've got here, we have to work with the size of angle A, go to circle, okay, we've got triangle here. Now we see angle, and this angle here should be equal to the angle made here, because the angle, this is a real simple example of theorem 6, because this angle here is equal to angle here, because angle in this segment, an angle in the alternate segment is equal. So angle A definitely has to be 64 degrees. So here, 64 degrees. Very easy. Okay, very easy. Okay, so let's come to the last second theorem, theorem 7. Now, this is another quite simple one, but let's look at it. It says the opposite angles of a cyclic, or some people call it cyclic, okay? Okay, in a cyclic quadrilateral add up to 180 degrees. Now we've got a circle here, and then we'll have a quadrilateral inside the circle. That's why it's called a cyclic quadrilateral, okay? Now, very interesting thing here is that the opposite angle of this cyclic quadrilateral always add up to 180 degrees. And the same thing here, the opposite angle here, always add up to 180 degrees. So we can see that here, A and B add up to 180 degrees, or you say X and Y add up to 180 degrees. That's quite easy to understand, right? Good. So let's come over to the right to see how we could really work this out. So we have here we're going to work out the size of angle A and angle B. So we've got a circle here, and we've got a quadrilateral inside the circle. So definitely this is a cyclic quadrilateral. And then we need to work out the angle A and B. But first, let's work out the angle A. Now we know the opposite angle of a cyclic quadrilateral always sum up to 180. So to get the angle, this 109 and plus angle A should give me 180. So to get angle A, all I need to do is to subtract 109 from 180 to get angle A. So that's gonna be 180. Subtract 109 degree, okay, and don't forget to put your degree sign, and it's going to be 171 degree. So angle A definitely going to be 71 degree. And then to find the angle B, the sum angle 88 and B should sum up to 180. Okay, so to find angle B, then I need to subtract this angle 88 from 180 to get angle B, and that's going to be 180 degrees subtract 88 degree, and if you subtract that, it's going to be 2 here left to near 7, and 7 is not 7 minus 8 is not possible, so I bring 1 here. We have 17, so 17 minus 8 is going to give me 9. Am I right? I think so. 92 degrees. So angle B definitely going to be 92 degree. I hope you enjoyed this video. And if you really like the video, I want you to hit the subscribe button and the like and share. Okay, now after this video, I'm going to have more videos where you're going to have more detailed work. Look out for it. Thank you. Have a great day.